Hi, and welcome to Group 20's Senior Design Project, Phonergy, the Smart Energy Meter.
So, what is Phonergy? Well, Phonergy was the creation of a group of individuals who noticed how wasteful people were being with electricity. We wondered if there was a way to create a device that was easy to set up and functional enough to provide accurate readings while transmitting data securely over a long-range network. The end goal aimed at one thing: helping people save money on their energy bill. Phonergy, the smart meter, takes the hassle out of setting up a smart meter in your home by implementing a fully wireless connection. This is where Phonergy takes a stride ahead of its competition. Instead of using unsafe and resource-expensive Wi-Fi, Phonergy uses LoRaWAN. LoRaWAN is a low-power, wide-area networking protocol that relies on node-to-node connection. The advantages of LoRaWAN is its long-distance communication, up to 50 miles, and TLS encryption that keeps data significantly safer than Wi-Fi. Phonergy works seamlessly, bringing energy readings in your home to visual, easy-to-read displays accessible at the click of the button on our Phonergy app. The Phonergy system also includes an appliance identification system that reminds you if appliances are being left on in the home after prolonged use, and spending notifications in certain areas of your home, such as the kitchen or living room. And to keep the ever so important hardware safe, Phonergy spots a fully weatherproof case, meaning it's suitable to any environment, rain or shine.
So this is the team behind Phonergy: Kenneth Thompson, a comprehensive EE; Alexander Kuzi, a power and renewable energy EE; Estefania Aguilar, a power and renewable track EE; and Nabil Khan, a power and renewable track EE.
Work distribution. In our project, we tried to keep the work as evenly distributed as possible, meaning that everyone had equal responsibilities. Due to COVID last year, testing had to be pushed back. To make up this time, we decided to split the project in three main sections: hardware, network, and software. Two of us worked on the software section and the other two on the hardware section. This allowed us to focus independently on either end of the project, coming together to implement software with hardware in the networking section. The hardware group, Nabil and Alexander, had a lot on their plate developing all the sensor circuits, power supply, backup battery system, transmission system, ESP32 programming, while the software group, Kenneth and myself, focused on the setting up of the digital infrastructure, such as LNS, Edge Gateway, AC2 instance, decoder, websites, digital wiring of services, databases, app development, and visual monitoring displays. Problems. While the software for most of the part of this project was problem-free, hardware presented some big challenges. Since our project involved so many different sensors and parts, finding all the through-hole components for testing purposes was impossible. The PCB boards were designed separately in such a way we can isolate which circuit was faulty. While circuit integration, most of the PCB worked. However, at that time it was clear that the power supply redesign was needed. Through troubleshooting, we found that the Texas Instrument chips, like the voltage controller, presented abnormalities. The chip weren't regulated the output voltage as the calculated and theoretical values on the datasheets. This problem was chosen for the time spent and the effort to overcome this issue. However, the lesson learned from this problem is that the quality of the materials must be carefully chosen.
Understanding the bigger picture. In a fully realized system, Phonergy could service a whole neighborhood, using one central gateway as a secure local connection. If enough people are using Phonergy in a particular area, we could even implement LoRa meshing to extend the range of a gateway even further. From the Phonergy device, we send information under a unique identifier, the product code, that helps us differentiate one smart meter from the next. When data is forwarded from the gateway, the LNS receives the data and decodes it. From here, it is pushed to its own individual database. When the customer creates an account on the app, the information it displays is dependent on the product code they enter. The product code can only be registered once to prevent the stealing of codes. Once on the app, Users will get all the notifications and displays related to that particular smart meter.
This is the Phonergy smart meter device in its natural habitat, designed to fit just under the breakers within a home's breaker panel. Phonergy is a non-invasive and easy to install device that was built to fit most residential homes. The sensor located near the top of the breaker panel measures the total current entering the home. As you may observe here, individual current transformer sensors installed throughout the panel capture the current readings of their assigned breakers as current flows through them. These readings are sent into the ESP32, where various data points are calculated and packaged into a small payload. From here, the data is sent via the LoRaWAN protocol to our edge gateway, where it is verified before being further transmitted to the cloud.
In this demonstration, our team member Kenny is seen entering the home and turning on the microwave. Shortly after the microwave is activated, our team leader Nabil, who is sitting at the counter nearby reviewing his home's energy usage for the day, receives a notification on his phone. This notification alerts Nabil that the microwave has been turned on, as well as the amount of power being consumed by the device. This functionality is a simple example of how the Phonergy smart meter can be configured to promptly notify the homeowner when a major appliance is consuming large amounts of energy at any given time.